So this is a review for the polar test, which is tomorrow. I gave the kids this r comma theta right here and said, hey, would you make that rectangular? And so one kid suggested that we use one of these. I call it a helper triangle. And then you can go, if we don't know what this is, we call it x. And x is to this as 8 is to 2. And then you can solve your little proportions. Our final answers were -4√3 and +4. The negative's easy to forget because when you're doing this, there's no negatives in it. You just have to realize that that's where you are in the big picture. That's why I say to always draw it. If you didn't draw this thing, you might not notice it was negative. All right, then here's another kind, and that's where we give you a rectangular, and you have to make it polar. All right, so what if I said it was at -1 comma excuse me, square root of 2. Can you tell me what that is in polar? I'm going to pause for a second while you guys work on this one. That's rectangular. Make it into polar. You'll need an r and a theta. Okay, I hope you drew it. -1 this way, and then square root of 2 that way. Oh, no, not that way. That way. So -1, square root of 2. And then, what's this last one? All right, now this part, a lot of people get confused because we've got 1, 2, and people go, oh, 1, 2, square root of 3. That's if it's a 1 regular 2 square root of 3. All right, so what's that one? It is root 3. All right, this can get really confusing. Now, how can we know that for sure? We do agree that if I take square root of, and then I square this one, which gives me 2, and I square this one, which gives me 1, and then since it's the longest side, I should add them. There's your proof that it's the square root of 3. Okay, and so then you don't just try to memorize every side of every triangle. You know, make sure you aren't, because the classic mistake here is to go, oh, it's 1, 2, and 3, and I already have a square root, so I'll say this side is 3. You got to make sure how long that third side is. All right, so square root of 3, comma, and then what's the angle? Do you know this triangle? No, then you can't just say, oh, well, cannot be determined, or NA. Then you have to give an inverse. And if I put inverse whatever here, what would be wrong with me saying this? Inverse tangent, toe is opposite over adjacent, square root of 2 over -1. What's wrong with that? Yes? Inverse tangent can't be there. Very good. So it's something like that. What function can be there? All right, so this could be inverse cosine. Oops, not tangent. It could be inverse cos. Inverse cos and cosine would be adjacent over hypotenuse, -1 over square root of 3. Did anybody figure that one out without me? Sweet, a couple of groups got it. All right, if you didn't, do you see that what I have here is an angle? Because inverses always are giving you angles. In case you forgot that, now you've been reminded. Okay. Next kind is in polar. A lot of times we will give you 2 equations, and you have to like set them equal. Kind of like if I gave you this, and you could just set them equal to each other because x is this. This can go here. Okay. Well, in polar, it's not going to look like that because in polar you don't have x's and y's. You have what? R's and thetas. Okay, so here's a typical one. What if r equals the square root of 3 and the other r equals cosine of theta? Oh wait, 2 cosine of theta, sorry. When you solve this, do you realize you've got one circle that's got a radius of like 1 point something? Do you have that one memorized yet? Square root of 3 versus square root of 2. Which one's bigger? Square root of 3, and it's 1.7. Very good. And the other one would be about 1.4. Very good. Okay, so that's just to ballpark it, so you can kind of know what you're thinking about. So this is a circle that has a radius of like 1.7-ish. And it's the whole circle. It's like the whole thing. And then the other one, Do you remember if cosine was the one that was sitting up here, like the red one? Or was cosine the one that was over to the right, like the black one? It's like the black one. Okay, so then ignore the red one for a second. I'll just get it out of there. Then do you get that the blue one and the black one overlap each other? All right. Now, I just sketched it. Is it possible that the black one could actually be so small that they would not touch each other? Yes, that would mean there was no solution. Could it be that the cosine one is just big enough to touch once? Is that possible? Yeah, and if it was, then there'd only be one answer for where they touched. Is it possible that the cosine one, when I actually graphed it, would be big, and therefore there's two answers? Yeah. All right. So remember, these are points. They're not just like an angle. They're points. R comma theta. It's just that the R is really simple because they told you what the R had to be. All right, so would you please find the points of intersection, also known as the solution to this system of equations, and do the substitution thing. I'm going to pause for a minute while you give that a try. Okay, so by now you should have figured out that that needs to go there, and you have square root of 3 equals 2 cosine theta. Then you divide by 2. Am I doing inverse trig, so this can only happen in a certain spot? Nope, this is not inverse trig. Don't forget that if it was, that there's certain places you can be, certain restrictions. So this doesn't have restrictions, so usually that means there's two answers. So I'm going to draw my pictures. Where can cosine be positive? Oh, students, take calc here and here. So I like to do it the other way where I cross out where it can't be. Okay, so let's say it can't be here and it can't be there. Now, it can be both of these two places. Here's my two answers then. Cosine is adjacent over hypotenuse. And is this the 1, 2, root 3 triangle? Yes, it is. And that makes this what's across from the 1 again? What angle's there? 30, also known as pi over 6. So we got pi over 6. And do we do the negative one? Nope. That's if you were doing inverse trig. This is not inverse trig. So then we give the other big angle, which is down here, all the way to there. A whole bunch of pi over 6s, specifically 11 pi over 6. Very good. And this again is a 1, so that technically a negative 1. We didn't really care that much because we really cared about the angles. And kids get to the end and they were like, sweet, I figured it out. It's pi over 6 and it's 11 pi over 6, and they get the whole problem wrong because that's not 2 points. What is the points? R comma that. And how big's R? Square root of, I think it was, wasn't it? Let me look. Ah, there it is. R equals square root of 3. So square root of 3 and then square root of 3. Does that make sense to you? Yes. Yep. Ah, it's a good question. Is this drawing to scale with the picture? No, this drawing was kind of like a helper triangle. It just gives you a generic answer. It doesn't give you the final answer. Why? Because if we were going to draw it to scale, we'd have to make that the square root of 3. The R has to be square root of 3. If you wanted to do this, you'd have to somehow take this 1, 2 square root of 3 and then factor by multiplying by something to make it the right size radius. So if you want to see what a picture looks like, all this is telling you is the angles. And then if you want to see what it actually looks like, you'd have to graph those. And then I can do that quick just so you get the perspective. Here's where 1 pi over 6 is. And here's where 11 pi over 6 is. And then how far out is it? The square root of 3. And so my two dots would be here and there. And that's where two circles would have crossed. The circle for the square root of 3, which is, of course, like this. And the circle for the cosine, which would have been like that. Okay? All right, so think of this as kind of like a helper triangle. They don't have to match the original triangles, but they still tell you they're helpful for getting the answers for the angles. All right, moving on. The next type of question you need to be able to handle. Converting from rectangular to polar. Can you please tell me what R equals when you're talking about x. What are you talking about, Mr. Server? R. I don't really want to say R equals. You could solve it for R, but that'd be a little weird. What's x, what's y, and what's r squared? I'll say it that way. And please don't just say x squared plus y squared equals r squared. That's great, but you need to know what just x is. Okay, random person. It's row 1, person 1. That's you. What's x? You talked to your partner about it yet? I would recommend it. I'm going to call on somebody else while you guys talk about what x is and what y. Okay, this is row 4, person 2. How about you? Do you know what x is? You're warm. Pretty sure x is a different one. There we go. So say it one more time. Yes, and the y? Yes. And the r squared is the same as? Yes. Okay. Then the trick to these is, what if you don't have r squared? What if you have r? Well, then you got to square it somehow, or times it by r. Okay. So let's say we had this one. This is a fairly easy one. I got to save some time and make some of these on the easier side. X squared plus 3x is equal to y squared. I'm not even sure what that would look like in rectangular. But my question is, what's an equation that would look exactly the same when you graphed it, except it has to be in polar? Change that to a polar equation. That would give you the same exact picture when you graphed it. Do you guys get that this is probably some morph of a circle because it's got an x squared and a y squared in it? Okay, so it's probably some type of circle. Well, how could we make that same drawing with polar? Don't overcomplicate it. Try to figure out where you can make some swaps and get all the x squareds and the y squareds out of there and leave the answer with only r's and thetas. I'll pause for a minute and give it a try. Okay, so this one didn't work out quite the way I was expecting it to. I was thinking, oh, they'll just move the x squared and the y squared onto the same side and replace it with what? R squared. But can you just do that? No. Okay, so then we're going to have to work a little harder at it. So if this had gone the easy way, you could have like added x or y squared to both sides and then replaced things. But how about this? Can we replace an x with something? Yeah. What can we replace x with? R cosine. Okay. So I just replaced an x with an r cosine theta. Isn't it a little strange that it's got a squared on it? Yeah, it is. It would have been nicer if I could have put the x and y together, but in this problem I couldn't. So then how about just plain x? We just did that one a second ago. We replaced an x with an r cosine theta, right? Okay, so this one, instead of just the 3x, we're going to 3 and then r cosine theta again. And then the y, that's an r sine theta squared. That has only r's and thetas in it, doesn't it? All right. Now, if you got these two together and factored out the r, then you'd have a sine. Oh, if they were plus. Let me just show you something. And I'm going through a lot of stuff that you probably never have to do on the test, so let's not do that. I was going to show you that you could probably get a sine squared plus cosine squared out of it. And what's sine squared plus cosine squared? That's equal to 1. So you could do some simplifying, but it's more complicated than that because it's actually an r squared that's in both of them. So, all right, let's just leave it that way, because how do we judge if we're done? If you only have r's and thetas left, it's in polar. So it's in polar and I'm done. I don't have to solve it for anything. You don't have to solve it for r. That'd be a pain if you did, but you don't. All right, then the last kind, which is the fearsome and much feared graphing questions. They're not that hard. If you had a calculator, it'd be super easy. But imagine for a moment, you had to graph this. What's your best friend in graphing? You can always count on it to figure out where the dots are. XY chart. And if I give you a bunch of dots on an XY chart, and they like seem to be doing that, does it kind of make sense if this is a cosine that it would be like over there? Yeah, I can kind of know that it should be over there. Now, can it go? Let me show you how it could go. The cosine can stray like to the left or to the right. It was a circle. A regular cosine would just be like this if you connected the dots perfectly and was just cosine. Okay, but you get it can go to the left because you're making your radius bigger. And so bottom line, your graph doesn't have to. I don't want you to think, oh, cosine has to be to the left of the origin because I know cosine's over here. Not if you stretch it or if you move it, it can go across the origin. All right, so bottom line, I don't know exactly how this thing looks. How am I going to figure it out? With an XY chart. Except it's not X and Y when you're in polar, it's R theta. All right, so FK. What should I start with, R's or thetas? Very good. And what would be good ones? Like pi over 12? Probably not, because you're not going to know what cosine of pi over 12 is. You'll have to do all of these in your head. Could you do cosine of 0 in your head? I agree. So everybody put in 0. What's another one that you could do cosine of with like a helper triangle or a quadrantal chart or yes? All right. And there's the only a few minutes left warning, but it is actually kind of accurate even though it's completely set for a different day. We are actually out of here at 12:33. So anyway, we should finish this puppy up and just do a couple. What did you recommend? I agree. That's going to be an easy one. It's a quadrantal. You can draw yourself a little picture. Pi should be doable. And let's do one that's not a quadrantal. Pi over 6. I like it. Would you please find those 4 points? Actually, there's 4. You already have the thetas. Just find the r's. How? You stick it in the equation and you solve it. I'll put it on my desk and you can have it back in a minute. Since we have so little time left, I just want to make sure you get what to do here. If we stuck a 0 in for our angle, we're trying to find cosine of 0 degrees. That's not a picture. I can't draw a triangle for that, but I can draw a quadrantal and say it's there because that's where 0 degrees is. And then that's the spot 1, 0. And so what's cosine at 0? It's 1. So this whole thing turns into 1. And then you have to solve this little equation and figure out what r would be. It says r minus 8 has to equal 2 times 1. And 2 times 1 is 2. And then we're going to add 8 to both sides. Did you get 10 for your r? Another way to think of it is this. I could add 8 here and add 8 here. And your equation could always just have an 8 added on both sides. That might be better for you. All right. So yes, your final answer was 10. Try it again for the pi over 2 and the pi over 6. I'll pause again while you finish this up. Okay, student says I should take cosine of pi over 2, which is that spot. And then how'd you do that? Cosine of pi over 2. 0, 1. So it's 0. Awesome. So cosine of pi over 2 is 0. And then tell me what to do. So r minus 8 is now equal to 0. Add 8 to both sides. R equals 8. Did you have 8 for this one? Raise your hand if you did. Okay, good. And I want to do 1. We're going to skip over this just for time for now. And go to the pi over 6 one because that one works out kind of different. Can you tell me EF? Tell me what to do, though. Okay, so you're figuring out cosine of pi over 6 by making a helper triangle. I like it. 1, 2, square root of 3. And then we found cosine of pi over 6 as what? Root 3 over 2. Very good. Do you see why I chose to put a 2 in front on the problem? Because root 3 over 2, the 2 here will cancel the 2 there, and what do you got? There you go. And so if you're going to solve it and get the 8 alone, you have the r alone, sorry. You'll have r minus 8 equals root 3, and then adding 8 to both sides, you could put 8 plus root 3. Now, would I like it even better if you said 9.7? Yeah, but I'd accept this, because how could I not accept that? Because that's even more accurate, really. Okay. All right. That's just for completion's sake, because we only have one little spot left and we have enough time. EL, can you tell me what you got for pi? That'd be this spot here. Tell me what to do. -1, 0. Cosine of that is -1, because it's the x part. 2 times the -1 makes -2. Now we have r minus 8 equals -2. And then what? Yep. Adding 8 to both sides does give you 6. Very good. So this should be a 6. Who else got a 6 for that spot? I think we can confirm that's right then. Okay. Can it happen that you come out with negative r's? Yes, you can come out with negative r's. And is that a big thing? Well, it is if you don't know how to graph a negative r. So just for the sake of argument, let's say one of your points had come out to -3 pi over 6. Put where you think that would be in your last 1 minute. We have 1 minute left. Where do you think that would be? Hint, it's not in the same place as 3 comma pi over 6. But I'd start with finding that. Here's where 3 comma pi over 6 would be. So -3 comma pi over 6, that must be over there. Raise your hand if you had that one right. Okay, awesome. Then, remember that your homework was to do 4 problems. I am not adding to that. I would recommend doing more. So when I ask you to Dropbox those 4 or more problems, you're going to Dropbox whatever you have done tomorrow to show me what you did for review. A minimum of 4. I recommend more. That's all I got for you for today.